Chapter 6 is this 6 weeks. Yeah, all of chapter 6 is this 6 weeks. All right, so here we go. First things first. I'm going to be out tomorrow, so I don't like doing notes 2 days in a row like this, but it's just what it is. It's not that bad. We just got to introduce it. We will probably do the graphing portion of it on Monday, which won't be long. It'll be real quick. You can probably do it on your own, to be honest with you. But we'll go over it on Monday. But we need to introduce logs. Now, logarithms are one of those things that a lot of people go, ugh, logarithms, ugh. But that, honestly, they're really not that bad. They're really not that bad. And I think it's partially because people don't know what logarithms are. They look kind of funky, and so they're like, You're right, it's its own language. You just got to learn to speak the language. But a log is an exponent. I think 17, 12, I don't know. 7.3. Wherever that is. A logarithm, 7.3. A logarithm is an exponent. Yeah, well, there's not separate. All right? They represent exponents. And they're extremely handy is if you have something like this. 4 to the 3x minus 7 equals 9. Can you think of anything that would work for an x that would get me from that 4 to that 9? Yeah, don't even try, okay? But what it does is I can turn the rest of it into a log so that I can expose that 3x minus 7. Okay? That is the purpose of a logarithm. All right? They are to expose exponents. All right? So first things first, logarithm with y of base b function. So basically what they're saying, they're trying to say, hey, log with base b, so we'll say base, of an answer, or argument, A-N-S-W-E-R. The technical term is an argument. For the time being, think of that as your answer. Okay? Equals the exponent. Likewise, if you had this as an exponent, as an exponential, the base to an exponential exponent would equal your answer. So let's unpack what I mean by that. So base to an exponent to an answer. So let's say 5 to the third power. Does anybody remember what 5 to the third power is?
30.
No. 125. 5 times 5 is 25. 25 times 5 is 125. So 5 to the third power is 125. This is your base, your answer, and your exponent, and your answer. Okay? If I wanted to turn that into a log, basically how we would write it is we would write log of base 5, log base 5 of 125 would equal 3. It is simply a way to rewrite these exponentials so that the exponent is all exposed. Okay? So if you ever have a crazy exponent you have to deal with, this is how you do it. You break into it with a log, and then you can have your way with it. All right? Every pun intended. All right? So here you go. You got log base 5 of 125. Okay? So here we go. There's a few other things. A common log. All right? Every so often we'll have a log without a base. So let's say a log of 25. Okay? Do you see a little number on that? A little base number? No. Does anybody know what that little number is? It is an understood 10. That is an understood 10. All right. Now that's because this happens so much. We use log base 10 so much that it gets its own notation. Okay. In science, it happens all the time. Like you remember dealing with pH values. You probably dealt with logarithms when you dealt with pH values in chemistry. And stoichiometry, you probably used it as well. Natural logs. Okay, that is a log of base E. Remember yesterday we talked about E as far as this is the that ratio of things that are happening continuously. All right, so like continuous compounded interest, we would use E. So that gets its own log as well. Ln, let's say ln of 25. that also is missing this little number down there. That is an understood E. Okay? That is an understood E. Now, why is it ln for natural log instead of NL? I have no idea. I have a few theories, but whatever. It's just what it is. Probably because log starts with L, so hey, it's a log of the natural site. Whatever. Okay? So that's basically what it goes. If you have a log with no number, it is either a to 10 or it's an E. If it's an ln, it's an E. Alright? So here we go. If you got a calculator, we got one next to you. Alright, y'all can show your glasses from over there. You've got two log buttons. The actual log button itself. Alright, the actual log button itself. What is the base of that log? It's what? It's 10. The one on your calculator is base 10. So if you have base 8, base 4, base 1/3, base 82, that is not the button on your calculator. Okay, it is log base 10. The one right underneath it is, one right under the log button is the what? ln. What is it have a base of? E. Okay, so these happen so often they get their they get their own button on the calculator. Okay, that is how often they happen. So ln is E. What's up? Did you say that's why it has a little e to the x above it? Yeah, no, that's absolutely right. Your ln button has an e to the x above it because they're tied with that e. Of the log has that 10 to the x above it because it's base 10. She's absolutely right. That's why it's that way. All right, so here we go. Let's keep rolling. All right, definitions of a logarithm with base b. Basically, here's the deal. If we have, what this is trying to get you to say, if log base b of x equals y, if log base b of x equals y, if and only if b to the y equals x. Remember, this is your exponent. A logarithm is an exponent. Okay, so that y is your exponent in this case. All right, any questions so far? This is just blanket information to absorb at the moment, but all right, let's turn the page. All right, what's up? Now there's a lot on that page, but this is a lot easier than you think. We're going to start off by, hey, going back and forth between a log and an exponential. And we're going to use something called, here we go, ready? Popcorn. Everybody loves popcorn, except for when it gets stuck in your teeth. Oh, that's right. You burn it. Yeah, I'm really good at burning popcorn. But anyways, here we go. Let's it says rewrite each log as an exponential. Rewrite each equation as either an exponential or a log, whatever. So here we go. What we're going to do is we're going to start with the base, go across to the argument, the exponent, and come back to the argument. All right? It's like a little piece of popcorn. So that would be 2 to the 4th power equals 16. Yeah, you did math model with me last year. You totally did. I know you did. All right. Same idea, letter B. We'll start with a base. What is another way of writing log base E? You remember?
You said what?
It's got its own button in the calculator. Say it louder, please. It's ln, exactly. Log base E is ln. So you could say ln of 1 equals 0. It has a little understood E down there. Okay, it's just not written.
Wow. We're feeling some type of way.
You know what, we're going with that. I have no idea, but we're going to have that. All right, so here we go. Again, start with your base, go across to the exponent, and come back to the answer. So that is E to the 0 equals 1. And that actually is a true statement, because anything to the 0 is 1, period. All right? And actually, this is a true statement. 2 to the 4th power is, in fact, 16. Cool? Yes, sir. Go to base, go across, and then come back.
So you just take out the 0.
No, you take out the ln, so E to the power of 0. No. E
is ln?
ln has a base in E. ln has an understood base in E right there. Did you have to rewrite this? No, but ln has a base in E. It is there, even though it's not written. All right, letter C. All right, let's see. We're going to start with the base. Your base in this case is 12. This little one. Boom. Come back. So 12 to the what power?
1.
Equals
12.
12. And that also is a true statement. Anything to the 1 is itself. Okay? Last but not least, letter D. What is your base in this instance? 1/4 or 0.25. That's fine. So 1/4 to the what power?
Negative 1.
-1 equals 4. 1/4 to the -1 equals 4. And again, this is also a true statement, okay? Because remember, what does that negative exponent do? It flips the fraction. It makes the 4 back on top. So 1/4 to the -1 is 4. Okay? Yes, sir. Sure. All right, try the next 4. E, F, G, H. Take, I don't know, 20 seconds. Do the next 4.
20 seconds. Next 4. Oh my.
I think you can do it in about 6, but
All of them?
all 4 of them. Just the next 4 problems.
So we do the next one.
E, F, G, H. Do E, F, G, H.
Bless you. EFGH.
There's really nothing to compute yet. Do the next one. 7 to the what power?
Third. Yes.
Wow. What are you paying attention to?
That's funny.
All right. Look up, see how you did. Cool. Beautiful. It's like exactly what we're going for. All right, how do we do this for? Give me 5-1. 5, I got 1, okay, 3 and 2 and 1, 6. All right, cool. Here's the part that you're really going to love. Going from a logarithm to an exponent and going from an exponent to a log is the same stinking thing. Wow.
It is.
It really is.
I remember. Not exactly, but I remember.
So start with your base. In this case, letter I. What is your base?
Isn't that
5. It's 5 to the 2, so your base is 5. Go across and come back. So that is log base 5, little 5, of 25 equals 2. Now, word of caution, when you write your log, imagine you have a line right there. Easiest way to think, imagine you're drawing a line. All right, just write it under the line, nice and small. Okay? Here's why I say that. If you write this, log base 5 of 25, that looks like log base 10 of 525.
That's how I write.
You follow me? I know. And that's why you're going to get them all wrong. No, but that's seriously, I will see these all over tests. I promise you. Don't do that. Or if you have to write big, just, if you have to write them all the same size, you physically cannot, write it lower at least. You follow me? At least give me that. Everybody can do that. What's up?
Oh, you stick in the calculator.
We're not going to put them in the calculator.
So,
You cannot put that in the calculator. We will teach you eventually. But you were ahead of me. But not yet. What's up? Sure. Letter J. Letter J. Again, your base. What's your base in this case?
10.
10. So 10 to the log base 10 of what?
2.1 equals -1.
Good. Base, argument, exponent. Base, argument, exponent. K. Same idea. What is your base in letter K? 8. So log base 8 of 4 equals 2/3. Use your popcorn. Letter L, same idea. What's your base in letter L? 6 of what? 1 2/16 equals -3. So log base 6 of, I'm going to write it like this just because it feels easier. That will be as a log.
You can feel special then.
Cool?
Yeah.
51.
All right, do the next 4. Do the next 4.
Oh, come on, come on.
not sure I want to know what that meant.
That means
Calm
it
down.
means calm
You said that calm.
down. Well, I don't know.
Separate out the palm pieces. Yes, it is. Look.
Cool.
Yeah.
Any questions, comments, concerns, public service announcements? All right, that's how we write them. Go back and forth, okay? We're going to get now into a little bit more about what they mean. Okay? So here we go. Evaluate each logarithm expression. Evaluate is just a fancy term for, hey, solve this. Okay? So let's think of it this way. We're not sure of what this equals. That's an eraser, not a pen. So let's kind of turn it back into an exponent. 4 to the what power equals 64. Right? Because this 4 to the what power will get me to that answer. So 4 to the what? Like 4 times 4 is 16. 16 times 4 is 64. So 4 to the third power is 64. So therefore, the log base 4 of 64 must equal 3. Okay? You kind of got to think backwards about it a little bit. All right, so letter B, same idea. We've got log base 5 of 0.2. So that's 5 to the what power would equal 0.2. Does anybody have any thoughts on this one? All right, let me ask you this. 0.2, does anybody know what that is as a fraction? It's 1/5. Good. 0.2 is 1/5. What would shove that 5 into the denominator? A negative. A negative 1. All right? So 5 to the negative 1 is 1/5. Therefore, log base 5 of 0.2 must equal negative 1. Cool. So you think 5 to what power will get me there? All right? That's the exponent it represents. All right, letter C, same idea. Log base 1/5 equals log base 1/5 of 125. So that's 1/5 to the what power equals 125.
So with a find whatever whichever power makes 125.
Well, think of it this way. You're right. What's one thing we have to do this 5?
Switch it.
Yeah, we got to bring it up. How do you bring it up?
Flip it. Negative 1.
Make it a negative. Okay, so that exponent we know has to be negative. That will take care of moving it up. But what will turn the 5, once you bring it up, into a 125? What power turns a 5 into 125? The third. 5 times 5 is 25. 20 times 5 is 125. So that is negative 3. Therefore, this log must equal... We did say it earlier, at the very beginning of the class. That was the very first notes we did. Plus, you probably should have 5 cubed memorized anyways. We've done it enough. All right, letter D. Just saying. All right, letter D, last but not least, this one. This would be 36 to the what power equals 6. Why would it be half? You stuck in the calculator, you got it.
0.5.
She's absolutely right. It is 36 to the 1/2, but why does a 1/2 exponent get me to the 6? What is it doing? You're on the right track, but what do we call it? Not square, it's square rooted. Good. Remember, a x to the 1/2 is the square root of x. Remember? So the 36 to the 1/2 will equal 6. Okay? So, a couple things to note. A couple things to note. If you're going from a larger number to a smaller number, there are 2 ways of doing it. Okay? There are 2 ways to go from a larger number to a smaller number. One of them is to make the exponent negative, okay? Because it turns into a fraction. The other way is to make the exponent a fraction, because that takes a square root, a third root, a fourth root, whatever. It takes a root. So if you're going smaller, those are the two ways you do it. Either a negative exponent or a fractional exponent, okay? Try E and F. Just try the next two. Don't do all four, just try the next two. Unless you're bored and you want to do all four of them.
I'm just gonna do.
Shut up.
And I'll put your sentence stems up here.
Oh, are you dancing? It creams you.
Come on, y'all. Okay, let's start here. 8 to the what power? What power would make this a 125? 125.
-1.
-1. Good.
How?
Another way of thinking that. Okay, so 0.125. What is that as a fraction? Do you know?
1/4.
Nope. That's 0.25.
Oh, 125? Or 12.5?
8.
Oh.
1/8. How many here liken themselves as either a carpenter, a plumber, or anything that you kind of do handyman wise? Anybody do that? Yeah, then you probably should know 1/8 is 0.125. That's a conversion you have to make often with a ruler. All right, just let you know. So, how do I move that down to the denominator?
Negative.
-1 equals -1. All right, the next one, 4 into 256. Well, 4 to the what power is 256? 4. That's the easy one. I keep messing this thing up over there.
Why?
-1. There we go. Okay, so hold up.
Okay.
64 to the what power will give me 8. What will take that 64 down to an 8?
1/2.
Oh, 1/2. You got to take the square root of it, so that's a 1/2. So that equals 1/2. Last but not least, 1/3. Now don't yell this out. Let everybody get a moment to think that hasn't.
You have your shit on you.
You're up here. I need you down here.
Okay, you got to do two things to it. What's one of them? You got to make it negative. You got to bring it up. All right. What's the other thing you got to do?
-3.
It's got to be a -3. No. I'm trying to give everybody a chance to think through it too. Because the negative will bring it up, and then a 3 cubed is 27. Okay? So how are we feeling about this? Give me 5 and 1. 5, I got this. 4, okay, 3 and 2 and 1.
Yeah,
5 was like the other day too.
I'm so proud of you.
Alright, so here's the deal. The biggest problem that people have with these is the fact that this is an exponent. It represents an exponent. And what it asks is this to the what power is the bigger number. The base to the what power is that argument. Okay? That's the way it stands. Alright, turn the page. Let's talk about another property. This is kind of like one of those funky little things like this that just kind of happens to be true. Shh, come on, y'all. Come on. So if I've got log base b, all right, my base is a little b, but then my argument is a b to the x. So if I have in the same thing a logarithm and an exponential, both in the same base like that, kind of weird. They undo each other. Those bases cancel out and you're left with the x. Okay? They're inverses, so they undo each other. Okay, they are inverses of each other. Exactly. The x because of the exponent. Exactly. There you go. All right, the same thing is true if I do it the other way around. If I have a base, but the exponent is a log base b of x, okay? Doesn't matter what order, whether it's a log with the exponential in there, or a base with a log as an exponent. They still cancel each other out because the bases are the same. Those cancel out, and you're left with the x. Okay? Now, the base has to be the same. It can't be a b and an a, or a 1 and a 2. They have to be the same. Okay? They have to be the same. But it's just one of those little tricks. All right, so here we go. Problem 3, letter A. First things first. This little log right there. What is its base? That's the argument. 10. Good. It's not the little number is written. So it's 10. So they have two of the same base, right? So you cancel out and you get 4.
Oh.
Cool. Log base 5 of 25 to x. Do you have the same base there?
No.
No, but 25 is 5 to the what power?
2.
Not to the 5 squared, exactly. So I can rewrite that as log base 5 of 5 squared, and the x comes along for the ride. Cool? Because a 5 squared is a 25. Yes, ma'am? I'll come back to it in just a second, all right? So now do we have the same base?
Yeah.
All right, so these cancel out, and what are you left with?
2x.
2x. All right. Problem A, you had a question about that. Let me rewrite this a little bit differently. This is a 10 to the power of log base 10 of 4. Does that help you out? Because that little 10 is right there, it's just not written. Because those are the same, they can cancel each other out, and what you're left with is a 4. You follow me? All right. Try C and D real fast. Try C and D.
18.
Yeah, the first one should take you all of 3 seconds. You're right.
Cross everything out, baby.
Essentially, but the next one you have to play with a little bit. The first one is self-explanatory. The second one you have to play with a bit. All right. Letter C. What's letter C? 18. Good. You got the same base. Wow, that's a beautiful 8, wouldn't you say? Those go away. Nope. Those go away.
2x there.
All right. Now log base 4 of 16. Are those the same base? Good. We can make it the same base. Turn the 16 into a what?
4 squared.
A 4 squared. So that's 4 to the 2x. Now those can go away, and you're left with 2x. Cool? All right, so that's just one of those properties that you just kind of need to know about. All right, they undo each other. All right, the last thing we're going to talk about this is finding inverses and things like that. Like I said, we're going to push the graphing off until Monday. All right, it will take us 10 minutes to go over. It's not that bad. You'll pick up on it real quick. But problem 4, find the inverse of a function. If you recall, an inverse is when we switch x and y and then resolve for y. Okay? So, but we're going to have to break into that exponent. The way we break into an exponent is by turning it into a log. All right? Or the way you break into a log is by turning it into an exponent. Exactly. So here we go. First things first, let's switch x and y. So this would be an x equals 6 to the power of y minus 3. Now I can't turn this into a log yet. What is the one thing in the way?
The 1?
The negative 3. This is my exponential. Before I popcorn it, I kind of need to move that 3 over. So we get x plus 3 equals 6 to the power of y. Now that little exponential is by itself. So we'll start with the base. What's the base? 6. 6 is what has the exponent. So 6 is your base. Go across the equal sign, grab the entire argument, and then come back to the exponent. So it would be 6, no, I'm sorry, log base 6 of x plus 3 equals y. Okay? Sometimes the hardest part for students is to realize is, oh, I can take all of that as my answer, or all of that as my exponent. All right? That's okay. All right? So base, argument, back to the exponent. Any questions on that?
No.
Comments, complaints? It is easy. You just kind of got to see the pattern. Once you see the pattern, it's really not bad. All right, letter B. Same deal. Start up, they want you to find the inverse. To find an inverse, you do what? Switch x and y. Good. So that's x equals 1/2 the natural log of y plus 3. So we want to get down to this so we can popcorn it out. What do we need to get rid of? The half. How do you get rid of the half? Sorry? Multiply by 2. Good. A 1/2 is divided by 2. So we multiply by 2. So it'll be a 2x equals ln of y plus 3. Okay. Speed up a little bit. So what is the base for that log? Well, if it's not written, it's one of two things. It's either a 10 or an e. Which one is this one? The e. If it's just log, if it just says log, it's an understood 10. If it says ln, that's your natural, has an understood e. Okay, there's your difference, okay? That's going to pop up a lot. We're going to drill that in a little bit. So, start with that little understood e. Go across, grab your exponent, and then come back and grab your entire argument. So that would be e to the 2x equals y plus 3. Cool. Grab the entire chunk. Move the entire chunk. Okay, so what's the last thing you got to do? Subtract 3, exactly. So e to the 2x minus 3 equals y. That is the inverse of the prior equation. Let me zoom out so you can see the whole thing. Cool. Does that make sense? What's up? Okay. Try letter C. I want to do both of those before we leave. So try letter C. All right. Sorry, Henry. So letter C. How did we do? And I'll erase all of that just so it's a... Oh, I thought you said something else. Just letter C. You can do letter D. Go ahead and do letter D. We're going to do it in a second. But any questions on how to get letter C? Anything about what we did?
That one is easy. I don't understand better.
All right, try letter D. Start off, switch your X and Y. I got you, Henry. We'll get it going. X equals 3 plus 4 plus 2. All right, how'd you do?
Oh, yeah, I got it.
Good.
Oh, damn it.
Sweet. Did we make it?